All right, in this video we'll discuss the cubic function. The parent function is y equals x cubed. You can pretty much generate this on your own. You really don't need a calculator for this because you guys have already learned how to raise numbers to exponents. So when you put in -2 and you cube it, you get a -8. -1 will give you a -1. 0 gives you 0. 1 gives you 1, 2, 8, and 3, 27, and so on and so on. So if you plot these points, you're going to get a graph that looks like this. And we did this graph back, I think it was unit 3. And make sure you include arrows on this. It extends forever up and forever down, and it also forever gets wider to the right and wider to the left. So our domain and range is going to be all reals for any type of cubic that you have. The next example is y equals -x cubed. And again, I'll just use the same y values that we did before. And you'll notice that the same x values. The y values are going to be the same, except they're going to be just opposite signs. So this will be a +8, +1, 0. This will be -1, -8, and -27. So it's going to look just like this curve, except it's just going to be reversed. So it'll go, it'll be decreasing. And again, don't forget to put arrows on your graph. And pardon how sloppy it is. It's all reals and all reals. Our next example is x cubed plus 2. And it's going to be the same shape as the one above it, but the +2 will cause the graph to shift 2 in the y direction, so it'll shift up 2. So if you just take the y values and add 2, that's how you'll get it. So if you do -8 plus 2, you'll get -6. For -1, if you did -1 plus 2, you will get +1. Of course, this was a 0, so 0 plus 2 is 2. This was 1, so 1 plus 2 is 3. This was 8. 8 plus 2 is 10, and then, of course, it was 27, so that'll be 29. So when you graph this, it's basically the same graph as above. It's just shifted up 2 units. So again, roughly, because I'm doing this pretty fast, this will be what your x cubed plus 2 looks like. The domain is still all reals, and the range is still all reals. For our last example, it's y is equal to x plus 1, the quantity cubed. As you can see, I've already generated a chart here, and you might not be able to tell quite as easy, but this is basically the same graph, except instead of being shifted up, it's shifted left. So the number in here causes the graph to shift left, whereas the number on the outside causes the graph to shift up. So when you're graphing your points for this one, you're going to go 0, 1, and then -2, -1, -1, 0. So do you see how it's just shifted to the left? So it's the same graph as y equals x cubed. It's just everything is moved over 1. And this is what your graph is going to look like. And again, the domain is all reals. So for your summary, you would put that the domain and range would be all reals. And the number outside the cube moves the graph up or down. And when I say outside the cube, what I'm talking about is the number that's not included, like in the parentheses. So if there's a number outside the cube, that will shift the graph up or down. If it's positive, it'll shift up, and negative, it'll shift down. And if there's a number inside the cube, that one will shift the graph left or right. And that is opposite of what you think. So if it's positive, it goes left, and if it's negative, it goes right. All right, the next part is going to focus on the rational function. Now with the rational function, you're going to have to rely heavily on your calculator because we really haven't learned enough to be able to do this on your own. So I'll say when you type this into your calculator, the parent function, 1 over x, pay close attention to the y values because you will see a word and it'll say error. So when you see this word, that's going to be where the function is not defined, which means you cannot include that in your domain. You're going to get a lot of decimals for this, so just round. So if you put in a -3, you're going to get a -0.3. If you put in a -2, you're going to get a -0.5. A -1 will give you a -1. 0, you're going to get an error, so that means that x can never be 0. 1 is 1. 2, you get 0.5, and 3, you get 0.3. And again, I rounded these. So what you need to know for the domain is your domain, you can write a couple different ways. You can write all reals, x not equal to 0. Or if you want to write it in interval notation, it looks like this. It's -infinity to 0 in union with 0 to positive infinity. Okay, that's what it looks like in interval notation. I don't really care which one you do. I went ahead and just drew the graph here. Now on your graphing calculator, it's probably going to look like it stops. You're probably not going to be able to tell that it actually extends up. So you just need to know that all rational functions, it's going to be this type of graph, and you're going to have arrows on both ends to indicate that it goes on forever in both directions. We've all talked about that the domain is going to be all numbers, but it can't be 0. So the graph is never going to cross over the line, the y-axis here. It's also never going to cross over the x-axis, which means that the range is going to be all reals, but y can't be equal to 0. And of course, another way to write that is simply it's from, oops, I messed up, from -infinity, here, let me correct that. It's from -infinity to 0, and then in union with 0 to positive infinity. The parentheses just means it can't include the 0. All right, for the next one, when you type this in your calculator, make sure that you put parentheses around the denominator, because if you don't, you're going to get a wrong table. When you put in a -3, you get -0.25. When you put in -2, you get a -0.3. -1 gives you -0.5. 0 gives you -1. This time 1 gives you an error, so that means x is not going to be 1. And 2 gives you a 1. So for your domain, since you got an error with 1, you're going to say that it's all reals, except x cannot be 1. And another way to write that is from -infinity to 1 in union with 1 to positive infinity. So when you go ahead and plot some of these points, right, the graph for this one is very similar to this. The only difference is, do you see how now this graph will not go over this line, the x value of 1? And it's the same thing, the y's, it will not go over the x-axis either. So for the range, you're going to again say that it's all reals, except y can't be equal to 0. And again, that's the same thing as saying -infinity to 0 in union with 0 to positive infinity. I don't know if you've picked up on this or not, but basically to figure out the domain, all you have to do is take the denominator and set it equal to 0, and that's the number that it can't be. Now we'll talk about this in the summary, but that's how I'm getting 1 for this one, whereas the domain for this was 0. All right, our final two examples. When you type this one into your calculator, again, you've got to make sure that you use parentheses around both of these. Otherwise, you will not get the correct table. Right, I got when you put in a -3, you get 0.5. A -2 is 0.3. -1 is 0. 0 is -1. 1, you get an error. 2, you get 3. And I'll go ahead and add 1. 3, you actually get 2. So I'm going to plot some of these points. All right, I went ahead and plotted some of these points, and as you can tell here, we talked about the domain. It has an arrow right here, so that means that it's all reals, except x cannot be 1. Or if you're going to write it in interval notation, it's -infinity to 1 in union with 1 to +infinity, because it never goes past this line right here. Now, a little bit different for the range. Really, you're going to have to just look at the graph. I mean, there's an algebraic reason for this, but for now, I just want you to investigate the y values and just look and see if there's a number it's getting really, really close to, but never actually reaching. And for this, if you continue to look at the values, especially if you change these to decimals and you actually got in between -3 and -2 and in between -1 and 0, you'll realize that it doesn't go above 1. So it like never touches 1. So it's going to also be all reals for the range, except y is not equal to 1. So that's going to be -infinity to 1 in union with 1 to +infinity, if you're going to write it in interval notation. In our final example, if you put in -3, you get a -1. -2, you get -2. -1, you get an error. 0, you get 2. 1, you get 1. 2, you get 0.6. And let me squeeze in 3. 3, you get 0.5. So you notice that x cannot be -1. So you can go ahead and put that it's all reals. X is not going to be equal to -1. Or for interval notation, it will look like this. Now we're going to wait on the range until you have the graph. For right now, the best way to figure out the range is just to look at the graph. So I'm going to plot these points. After plotting a few of these points, you can see that it's never going to cross over this line -1 right here. And the y values are never going to cross over the x-axis, which means that the y values cannot be 0. So all reals, y not equal to 0. In interval notation, that will be -infinity to 0 in union with 0 to +infinity. So summary for this is, for your domain, what you have to do is look at your denominator. So to find your domain, you look at denominator. Just remember domain, denominator. And you set it equal to 0. You solve it. And that is what x cannot be. So, for example, just to make sure you get it, for this one right here, if you just set that denominator equal to 0 and solved it, you would get x equals -1, and that's the number that it cannot be. For this one, if you just take your denominator, only the denominator, and set it equal to 0 and solve it, that gives you what x cannot be. Now for the range, we're just going to say look at the graph. Just look at the table, look at the graph, and figure out what it can be. So for the range, you have to look at the graph and table. And that is it.